Mr. Love here, coming to you from the Diesel Lab. Today we're just going to do a quick little video here on kind of how our alternator works in the simplest form and how to test it both on our test board here and out on a vehicle. We'll show you guys how to test both the amperage of it and the voltage output of it. Let's get started. Okay, so in its simplest form, to make electricity, all we have to do is pass a magnet past a coil of wires. So it doesn't matter if it's a wind turbine, a gas turbine, a steam turbine, nuclear steam turbine. It's all the same principles here. Basically, they just either turn into a generator or an alternator. Basically, it's just a magnet going past a coil of wires. So we just have our simple magnet here, run it over a coil of wires right here. You can see on our multimeter here, we're making voltage just by taking this simple magnet here, going across this coil of wires right here. So no tricks or anything there. It's just a simple coil of wires wrapped around, connected to our multimeter. We can do it on AC or DC here. So right there, we have alternating current. We're being made, not very much of it. We're at about 0.05 is our max output for voltage there. I could put it on DC too, and we could see DC readings on here going past there. You can see it's going from negative to positive as I'm going across there. So I'm changing the direction of the current there, but still the same idea. So simplest form, magnet going across the coil of wires. When we talk about our alternator and our automotive stuff here, our alternator, very simply, we have a coil of wires here. Inside that coil of wires spins our electromagnet here. So the more powerful of a magnet we have, the bigger coil of wires that we have, the more voltage we could put out. Obviously, for our car, we don't want to put out too much voltage, so we'll have a voltage regulator and stuff built into this here, where it can only go up to 14.4, 14.5 volts. So we have our electromagnet here. And we just have a coil of wires. This will be connected to our engine, just spinning around here. As it spins around, that magnet just spins inside the coil of wires. So simplest terms, that's an alternator. In a generator, it's just the opposite. It's a coil of wires spinning inside a magnet. So if this was a generator, this outside piece would be just our magnet, and the inside piece would be our coil of wires spinning around. But for our alternators, makes a little higher output for our small, 12-volt systems here. We have our electromagnet and the coil of wires. Okay, everyone, so over here at my board here, you can see we have an alternator here. We got a belt that goes down to just electric motor here. It's a 110-volt electric motor where I can just turn it on with a switch when I want to turn it on. You can see right now we're only at 10.88 volts. The battery's not up to charge or anything right now. But we could still test our alternator here to make sure it's putting out. So I'll turn on my switch here. You see our voltage won't raise at first. It's because I don't have my electromagnetic magnet inside here energized yet. So usually in our car, we have power going there every time we turn on our key switch, but I'll just show you the simulator right here. I don't know if you'll be able to hear the difference in the tone of it on the actual film here. Okay, so I just turned it on. You can see we're not producing any electricity. Right now I'm going to flip the switch here, and it's going to energize my magnet inside there. So now we just had a change in tone there, and now I'm producing electricity there. So I'm only at 12 volts right here. Our little electric motor is not spinning as fast as it does on our truck out there that we'll see here in a second. So whenever on my vehicle I want to see if the alternator or generator is charging, I'll have a bigger red wire that goes all the way back to the battery. Okay, so on my alternator here, whenever I go to test it, doesn't matter what it's on, doesn't matter if it's on a tractor, a car, a truck, anything that's, has an alternator on it, we can test it pretty simply here. So basically we'll have a big wire coming off of it. Some of them might have a ground wire and a positive wire going up to it. Some might just have a positive wire and then be grounded through the case of it. As you can see on this one here, we have this ground wire here, and we have this bigger red wire that goes back to our battery. So when I want to test it on my vehicle, to make sure that we're charging, what I'm going to do, I'm just going to take my positive one there, just stick on the red one there, then my negative one, I can stick right to the case of the alternator. So when I stick it to the case of the alternator, you can see I'm charging right now. Right now it's putting out almost 13 volts there. It's jumping around between 12.9 and 13 volts there. on my multimeter. So remember, our 12-volt battery is a fully charged one. It's actually 12.6 volts. So usually our alternator is going to be putting out, between 13.2 and 14.5 volts, depending on the need of the voltage going back to it. So one thing we are checking for right now is our voltage. Make sure we have voltage coming out of there. So again, we should be above the battery voltage when it's actually operating. So again, positive stuck on there, negative stuck to the case, or any ground that we can. That's a good ground. And we can see that we have 13.24 volts right now. I can also do this check back at the battery to make sure that it's charging back to the battery. Okay, so that's a voltage check. So voltage is good, so we know that it's producing electricity that's going back there, but we don't know how much is flowing back to our battery right now. So another good test we should be doing, if you have the means to do it, is checking the amperage going back to our battery. So most of our multimeters, if we just did an inline amperage check with it, refer to other videos for how to do that. But if we just did an inline amperage check, we could only do 10 amps with this because it only has a 10 amp fused one. So usually what we'll do is use a meter with an inductive pickup. So here I have my meter with multimeter with an inductive pickup on it. So the inductive pickup is just this little clamp right here that goes around the wire. When it goes around the wire, it senses how much electrons are flowing through it right there, and it will give me an amperage reading on the electron flow going through there. So when you do this, make sure you have a DC one, because remember, we're doing direct current back to our battery. So this one I picked up at Lowe's a few years ago. It's like 60, 70 bucks. They probably still have them there for around the same price point, but just make sure you have a DC one. So this one here, I'm going to just set the 40 amp DC. I'm going to stick it around my positive wire there. You can see that I have around 10 amps going back to the battery. So I've seen it multiple times where we could have a big wire here that's frayed, that's going back to the battery. So we might still be putting out voltage here, but it doesn't have the amperage flow going back to the battery. As long as we have one strand connected the alternator to the battery, we'll see voltage, but we might not have amperage flow if we don't have all the wire strands inside our little wire there. So it's always a good idea to check both the voltage and the amperage flow from our battery. So here I am out at the chuck here. So it's a diesel chuck here, so it's a little loud. International 4700. So you can see my alternator right here. We got the belt right off the engine, going down the alternator, spinning it there. So if I wanted to check the voltage on this, just like we did inside a second ago, I just take my positive lead here, my red one. I touch the red wire there, the battery output. And I touch the other one right to the case right there. And I should be able to see charging right now. So right now I'm just putting out 12.3 volts there. I have a little ground in this. Should only go to the middle ground here. Alright, that's a little better. So this one here has its own wire right in the open for the ground. So I can get right here and get a good connection on there. So I got my back lead there, touching the negative wire. I got my red one touching the positive wire there. And you can see I'm putting out 13.7 volts out of my alternator going back to my battery. Okay? So we know the voltage is good there. Let's check the amperage going back to our battery real quick. Again, just our inductive pickup. We'll set it to DC. Then we'll put it around whatever wire is the easiest to get to. We can put it around the ground wire there. You can see we're about 9 amps going back to the battery right now. Put it on my positive one. Pretty close to the same right now. Right now we're at about 9.5 amps going back. So my amperage going back really depends on how much load my battery's calling for right then. Quick again with the truck off so we can hear a little bit better here. So again, I just have it on voltage DC there. I take my positive lead, I put on the positive output post of the alternator there. I take my negative lead and I could put out either on the ground wire here or right to the casing if I could get a nice clean ground. The biggest thing is where I can get the cleanest ground. So this one has a nice wire right here, so I'm going to go right off the wire. Then if it was running, I'd be able to see that it's charging. But doing it right now without it running, I can see whatever the battery voltage is. So right now I have 12.56 back at the battery. If I fired it up, that's going to be up to 13.2, 13.6, somewhere in there. So quick little voltage check. And again, our voltage only tells us if it's making electricity. It's not really telling us how many amps are flowing back to the battery, how much flow is going back. So that's where we need our inductive pickup. I set it on DC here, and I'm going to put it around. I can put it around my negative one. The reading's usually not going to be quite as accurate as around our positive one. So whenever I can, I'm going to put it around our positive one. On some of them, they're in tight wire loom and stuff like that where you can't really get to it. But at least one or the other, that way we can at least see that we have some amperage flow going back. If we want to see the exact amperage flow, we're always going to go around the positive one. But if we want to see if there's just some amperage flow, we can go around either one. So that's our alternator output test there. So remember, we'll check the voltage and the amperage on it. Quick little check there. Literally takes 20, 30 seconds. We want to make sure our alternators up to snuff. The biggest thing we want to do with alternators is we don't want to charge the battery up constantly with it. If we have a bad battery that's going bad, you got to charge it up all the time. You have to jump start it all the time. That's the leading cause to alternator failure, is overworking the alternator. So the best thing we could do, have a good battery in there, have a good alternator on there, and our system will be good to go. Thanks for watching.